Swayam Prabha. Digital India. Educated India.
Good day, and today we start yet another lecture, and we are going to continue with the last lecture, that is waste minimization by integrated solid waste management. Last time we looked at the principles of integrated solid waste management. The large thought was reduce the waste to the extent possible, that is minimize the waste by whatever methods that you can, and then dispose the waste on land in a safe and environmentally sustainable manner. So let's quickly look at one or two slides we did last time, and then let's continue from there. So what we said last time, minimize the waste, effectively manage the waste till produced. So the hierarchy of waste management options were waste reduction at source, resource recovery through recycling, resource recovery through waste processing, waste transformation, and waste disposal on land. And we said that an industrialized society is taking energy and raw materials from the environment and giving out solid waste. The solid waste is produced by the industry, and the solid waste is produced by the consumptive processes in a city. And if we apply the principles of integrated solid waste management, we can apply them here to reduce the quantity of waste coming out and sending back the material and the energy to reduce the energy and raw material required by the industry. And similarly, after the consumptive processes, we can send back the material which we can use for recycling, or we can send back the energy which we can by burning combustibles, we can therefore reduce this. So let's recall that we said last time in India the waste composition looks like this. And let's see if you conceptually apply this integrated solid waste management, what can we do? Let us assume that we have 100 units of waste. Then we can reduce the quantity of waste by sorting at the source. This can take the form of sorting at the household level, that means within the houses, and after sorting at the household level, further reduction can also be done at a central sorting unit. That means at a facility where this waste reaches from the various households. At the central sorting facility, you can do manual sorting or mechanized sorting. Manual sorting typically means that the waste is moving on a conveyor belt, and you pick up the various items manually by hands. You are of course wearing gloves, and you are having some kind of a mask to prevent any pollution while you are doing manual sorting. The other way of doing sorting in the central plant is by using mechanized equipment such as screens and trommels, air separators which will separate out the lightweight material, magnetic separators which will take out the metallic materials, and even shredders which will cut open the plastic bags to release the recyclables inside the plastic bags. So about 10% of the waste can be reduced by sorting at the household level and at the central sorting unit. The remaining 90% of the waste would be C&D waste, biodegradables, combustibles and others. Typically, the C&D waste may be 15% of the total waste. The biodegradables comprising of the food waste and other waste such as wood and other garden trimmings would be about 30%. The combustibles, which could typically be paper, plastic, cloth and textiles, could be 20%, and others could comprise of intricately mixed material which cannot be separated out into the individual components for recycling. So, the C&D waste can be sent to a C&D processing plant where it can be processed for reuse in construction. The biodegradables can be sent to a composting plant or a biomethanization plant where the output would be compost, which can be used by the farmers, or the output could be methane gas, which can then be used for producing power. The combustibles can be sent to a waste to energy plant for generating energy, or the combustibles can be compacted and converted into refused derived fuel, either in the form of pellets, or it can remain in the uncompacted form as fluff. Now, at each of these plants there will be some pre-processing rejects, because all the material which reaches the plant is not 100% processable by the equipment in the plant, and after the processing is over there will also be post-processing rejects. For example, when you are doing composting, then after the composting you might sieve the material through 4 millimeter sieve, and the finer material may be the compost and the coarser material may be rejects. So, the product will be the bulk output and the rejects will be the minor output. Typically, all these rejects will go to the landfill, and the rejects which were coming from the others as well, because it is too intricately mixed for reuse, will also come here. So, all these rejects as well as this reject will go to the landfill. Now, let us see that we started with 100 units of waste, how much of it is going to go into the landfill. We have 15% C&D, and you will have about 15 to 20% rejects. So, 3 units are rejected. Similarly, out of the 30% biodegradables, 8 units are rejects. In the combustibles, you are having 5 units as rejects. So, if I total all these, 3 plus 8 11 plus 5 16 and 25 which are intricately mixed and cannot be separated, about 41% of the material has to go to the landfills. So, what good integrated solid waste management does is to reduce 100 units of waste to about 40% or less, and therefore, the size of landfill required is lower. I think I have another diagram here which we can go through. I don't know how clear it is, but it essentially captures what I said. We started with 100, and we did source sorting, intermediate, central sorting. 10 went back for recycling. Construction and demolition 15. Special waste sometimes, you can't do anything about it. Combustible waste, biodegradable waste. The figures are different here from what we've written on the board. That is not important. What is important is to recognize that there may be some hazardous waste and there will be some mixed waste. And not shown in this diagram, and that is erroneous, is that from each processing unit, no, it is shown here, from the biodegradable waste you will get rejects. Not shown in the combustible waste, you will have pre-processing rejects as well as ash. Post-processing reject of a waste to energy plant will be ash, and pre-processing will be all that material which they think will not burn. They will return it or say, please take it away. So in this diagram, I think it's about 45. And this diagram also says or presumes that your city will have 3 types of landfills: the hazardous waste landfill, the non-hazardous waste landfill, and the inert or the construction and demolition waste landfill. And this material will reach these locations. So I'd like to look at some recent initiatives in Delhi. We've been trying to process waste for quite some time in India. I mean, the last 20 years we have made lots of investments into waste to energy plants, composting plants. Many of them have been unsuccessful. Many of them have been unsuccessful. In fact, it is the rare processing plant which is successful, and the main reason has been the quality of waste reaching the plant. You cannot send mixed waste to a waste to energy plant. So you will find Bombay City signs a contract for waste to energy. Lucknow signed a contract for waste to energy 10 years ago. It didn't work. I already gave you the example that Delhi did it about a couple of decades ago. It didn't work. So if you send them only the combustibles or the better types of waste, that is what will work. And then the plant has to be designed for those combustibles. If you send them mixed waste, which is predominantly wet, it's not going to work. And a large number of composting plants have not also worked, because it's not just about composting the whole waste. Once you compost the whole waste, it is going to have wires, it is going to have plastics, and a farmer is not going to pick up that compost. He wants a very high quality compost for his fields. So composting plants have also not worked. We'll come to that later. But the more recent initiative is that we have 2 construction and demolition waste processing plants in Delhi. Please note, the moment we get into the C&D field, we are able to almost remove 25% to 30% of the waste from the main waste. So that's a huge reduction. And what do you do with C&D waste? We can reuse it. Suppose I'm got building construction waste, I can use it not as high quality aggregate, but I can use it as aggregate when I'm doing flooring. I can use it for embankment construction. I can use this aggregate for whatever purposes it meets the requirement. Suppose I'm relaying a road and I'm excavating the asphaltic and the bituminous layer, I can reuse it in the next road. So at Burari, we have first 2,000 tons per day capacity plant at Burari, and another one of 500 tons per day, which is going to come up or might have come up very recently at Shastri Park. So just a few photographs from the Burari plant. So what is a construction and demolition waste plant do? It gets the waste, it crushes it, it removes the metals and the other materials which are like pieces of wood, and then it sells off this crushed waste by first screening it. Maybe you can get sand out of it, maybe you can get gravel out of it, coarse aggregate, fine aggregate. So you can see a variety of heaps here. So it's like a crushing and screening plant. So the waste will come, it will go to some crushing units, then it will screen, and then it will be collected and sold off to various people. And sometimes you can also make a end product. So this is the waste which comes in typically. This is being there again. Not if you don't want to do a very high-end job, you don't want to make high-strength concrete from this aggregate, but you can make paver blocks. Paver blocks are not requiring a very high level of the quality of the input of the coarse and the fine aggregate into it. So they are making paver blocks here. Here, the finer portion of the construction and demolition waste, because many a times construction and demolition waste will also be having some soil mixed in it. When you demolish a building, the foundations will come out, you will be excavating it. When your excavator is taking out the waste, so they have used that finer material in a road construction. So we looked at construction and demolition waste. This plant is now doing well. I think the whole issue is about how you price it. If you are going to price recycled material, should it be lower than the original material or higher? Suppose I can get sand at X hundred rupees per cubic meter. Now I have recycled sand. Should it be less or more? Yeah, so if I am getting sand at 500 rupees per cubic meter, natural sand, and if I start selling my recycled sand at 700 and say I am green technology, sustainable, environmental friendly, you are making a house, you say you may be as much friendly as you want, I am getting the 500 rupees, why should I buy the sand at 700 rupees? So the criticality is, can we price it lower? And if we can't price it lower, let's say 700 rupees is the cost of production, then what is the alternative? We have to be subsidized. And who will give the subsidy? The government. That's where I talked about hierarchy of waste management options. The maximum subsidy should be given to making recycled materials sustainable. Subsidy should not be given to make landfills cheap. Because if you make landfills cheap, all the waste will come to your landfill. So we have to reprocess that. So as I said, Burari is successful as long as the pricing becomes successful and the subsidies become successful, which is a huge gray area. I'm going to look at the Hyderabad landfill site. This is an old landfill site which has been given to a private operator, and 1500 tons of fresh waste comes in here every day. 1500 tons is a lot. How many trucks do you think that is? Just to get an idea. One truck is how many tons? Well, density of waste is very low. Don't think that I am filling the truck with sand and I am filling the truck with concrete. I am filling the truck with all this food waste and yard trimmings. It will probably get 3 to 4 tons in a normal truck you will get. So 1500 divided by 3 is 500 trucks. And divide 500 by 24 it is. If every hour, how many trucks reach the landfill? Just to get an idea. 20 trucks. And if you are only working 8 hours, then divide 500 by 8, how many trucks reach every hour? 1 truck per minute. Before you can unload the truck, the next truck is in. Well, that's a fact. That's the way, that's the quantity of waste that is being handled at this site. So that's the municipal solid waste which comes in at the Hyderabad landfill site, mixed of all kinds. That's the covered area in which the composting and the RDF are separated. The most critical operation is trommeling or screening. When the fresh waste comes, it is passed through a series of screens. And I presume this is the coarse screen, which we will talk about. So the waste comes, it is first shredded, and then it is screened. Screened means it will be rotated in this. This is not the kind of sieve we have in the soil mechanics lab. This is a rotating screen. You pass, it's inclined, so you put the waste at one end, it travels down the rotating screen. Below the mesh, it will fall down. Above the mesh, it will be coming out as a reject or as the oversized material. So you can get an undersized material and an oversized material. So if a material comes in, I want to put it into 3 fractions, I pass it through a 100 mm sieve trommel, then a 30 mm sieve trommel, and then a 5 mm or a 8 mm sieve. So I can get those fractions. So here what happens? This is the finer fraction. I think this is 20 mm down of the waste which has come in through trommeling. And composting is a simple process, aerobic composting. You have to aerate it, allow a lot of oxygen to come into the waste, and you have to give it moisture. So aerobic composting means you make long lines of waste, long lines, and every day you turn it around. Why? So that the oxygen can go into it and you apply some moisture to it, and after a few weeks this will have become soil-like, or it can be something which can be applied to soil as a manure. So this is the composting windrow, as we call it. Eventually the compost is filled up in bags. It's available to you like a fertilizer bag. You can see inside the fine compost. So there are pre-processing rejects which come out from the screen. There are post-processing rejects. After the composting is over, they again pass it through the screens, because people buy fine compost. They don't want any coarse sand-like material to come, which is not going to hold water for the plants. So this probably is 5 mm down, and this is packed in bags. Now, luckily for us, compost is voluminous. So if a farmer wants it, he needs to carry it in a small tractor or a trolley. He can't just take one bag behind a bicycle. If a farmer wants to buy a fertilizer, an NPK fertilizer, he can put a bag behind his bicycle, and he can spread it with his hand in a field. But you want to put compost. Compost is a soil conditioner. It is not a fertilizer. It's like manure, humus. So you need large quantities. So luckily for us, the Supreme Court has ordered all fertilizer companies that for every few bags of fertilizer sold, they should sell 1 bag of compost. It's incumbent on them to place it in their showrooms. So this is going to a fertilizer company, which is then dispose it from its various showrooms. When you go to get petrol filled up in Delhi in various petrol pumps, you will find that some bags are available. That may be compost from gobar, or it may be cow dung. But even now, municipal solid waste compost is beginning to come into the picture. What happens to the stuff which was bigger than that 100 mm sieve? So that is the coarse fraction, and the photograph is not very sharp, but it has a lot of cloth rags and plastics in it. So at this location, the fluff, this was being sold as fluff, not as pelletized RDF. Please distinguish, RDF can be pelletized and RDF can be fluff. Pelletized means it goes like pellets, small briquettes. Fluff means it goes like this into the feed. So if you are sending this to a cement manufacturing plant for burning, because they need a lot of coal to burn, they have to modify their inflow feed, because this is not like coal. Coal goes in the form of crushed powder into a boiler where it has to burn, into a furnace. So here the coarse fraction is being sold to one of the cement plants. So they are handling 1500 tons, but they have some kind of a 25 rule, 25, 25, 25, 25. I said, what is this 25? He said, 25 is reject, sir. Okay. 25 is above 100 mm, which is fluff. Okay. And 25 goes into compost, and some 25 is what? You see, there are products of reaction. So don't think everything is 100, totaling to 100. They are products of reaction. Already the waste has how much moisture content when it comes in? Pretty high. So 25 will be water. That's a thumb rule. This is not given in any book, please. This is the thumb rule from the private operator. Let's look at the Ghazipur landfill. We talked about it. I showed you that slides where it's right in the middle of Delhi. And that's the landfill. How high is it? I don't know. But now, this was the landfill a few years ago. Now if you go next to the landfill, you have a huge industrial unit. What do you think is this? Yeah, it is a waste to energy plant. It's a waste to energy plant. So all the fresh waste is now going to go there and be burnt. I understand they are having some teething troubles, because if you get in fresh waste, you better have a composting plant also. If you try to burn the whole waste, mass burn is, that's what is called, and that is what is being done at the Okhla. There are all kinds of problems. You want to run a waste to energy plant efficiently, please use the combustible fraction. Remove the wet fraction, use it for composting, but that requires you to put up a pre-processing unit which is huge in nature. Anyways, it's having teething troubles. It's been up since 2015. Sometimes it works, sometimes they are adjusting to it. Finally, we will be able to adjust. But and incidentally, this chimney is 40 meters high, and this dump is higher than this chimney. So just to get you the idea of the dump. Qutub Minar, always we should remember, is 74 meters high. So we are all competing with Qutub Minar in terms of waste dumps. So that's the future of Delhi. That's the future of Delhi. So if you look at, this is a slide from a presentation made by the chief engineer of the municipal corporation, one of our alumni, and we have these grandiose plans about how well we handle this waste. So if you look at the capacities now, we have a waste to energy plant at Okhla, which is getting 2,000 tons per day, which I said is the mass burn, which is always in the newspaper because the residents are always up in arm and complaining about odor to NGT. The Ghazipur one is getting 1,300. It says it's operational since 2015, but I think it's operational in fits and starts. And the Narela Bhavana one is under construction, but this is the one which is with a private operator, and he will only use the fluff. So he will separate out everything. We have a compost plant in Okhla. It has become operational and operated many times and shut down and operated and shut down. Too much odor for the residents. Not selling compost. The biggest problem with compost plants is what? Can you sell all your compost? You can manufacture a lot of compost, but can you sell it? And in the bargain, offset your costs of producing the compost. So that's one, and there's one in Narela Bhavana. But I think all of them are surviving with this fertilizer companies having to take the compost from them. Does the compost meet food standards? A big question mark, because as I said, there is a different standards in different countries. In some of the industrialized countries, mixed waste, if you compost it, it is not allowed to go into the food chain. Can't be used for crops, can be used for gardens and flowers and other non-edible crops. C&D waste, Burari has started. Shastri Park, it says, has just started in 2015, and another facility is on. Now with all this, you feel maybe the whole of Delhi's waste is taken care of. 2,000 and 2,500 is 4,500, 5,000, 6,500, 7,500, 8,500. You should actually have no waste. Delhi produces about 8 to 10,000 tons. But we have waste in Ghazipur, I've shown you. We have a Bhalaswa landfill. I've shown you the Okhla landfill. The first shot which I show you always with black leachate at the bottom of a mountain is the Okhla landfill. And all of them are getting waste still. All of them are still getting waste. And this is with the private operator, Narela Bhavana, which we are showing here. He's putting up a waste to energy plant, he's put up a compost plant, and he has a landfill for the rejects. Let me show you some very few slides briefly from my experience. I had gone on a trip to the Netherlands as a part of a European Union project which we were doing with TU Delft, and there was a Chinese university, and everybody was taken to see the waste processing sites. We showed our Indian sites. We were the best in showing our dumps. And the Netherlands was the best in showing their processing facilities because they didn't want big dumps. They can afford it. It's, nothing to be ashamed of. Chinese didn't show us anything. So it was an issue about transparency versus opacity. There was a lot of presentations in the workshop in the university there. So that's a huge waste to energy plant in Amsterdam. And at that time when we went, and I think I went in 2006 or 7, this was the world's biggest waste to energy plant. And that's what it looked like. It looked like a power plant from the inside. You were not allowed much photography. We got some special permission, but that's the furnace where the things were burning. I don't know whether you can see. This is a grab. So all they were doing is the waste is dumped in a huge room, and a grab picks it up. And the grab picks it up, and what happens? Then it takes it for burning. So do remember that when a grab picks up a sample from the top, the heavy fines are at the bottom. If there is a soil-like material, the top is the fluff. So I'm not saying they were doing this. They probably didn't have the fines, but I'm told the same thing is done at our Okhla plant. You allow the waste to come in and just pick up. You don't want to set up a pre-sorting unit, it's too expensive. So what do you say? You tell your grab operator, pick it up from the top. If you pick it up from the top, then it's the lighter material. The lighter material is the plastics and the wood and the cloth and the other thing. Anyways, it goes to a furnace. The only message I would like to tell you is that there's a lot of ash which comes out of this. So don't think a little bit of ash. It's a mountain of ash. If you don't know where it ends, even I don't know where it ends. And this is hazardous, by the way. A non-hazardous waste. Why is it hazardous? Because it has leachable heavy metals on it. So it has to be disposed of in a particular way. Ash may also be non-hazardous. It's not necessary. So it depends on what was mixed in your waste, right? So maybe Indian ash will be non-hazardous. Maybe we are not as industrialized. We don't throw so many chemicals into our municipal solid waste. But this has to be then put into a hazardous waste landfill. Or you have to fractionate it and see which part doesn't have the leachable heavy metals. See, when you burn something, the heavy metals also vaporize, and then you cool it, it settles onto the outside. So maybe the fly ash has more heavy metals, the bottom ash may have less, so that has to be seen. They had a separate unit for tires. Tires are difficult to dispose, they are non-biodegradable, and you can recycle and retread and recycle and retread, but after that what do you do? So here we make, in Netherlands, you break up the tires and make them into very, very small pellets, like gravel. So the tire pellets can be used to substitute gravel in drainage beds. You know, you have a garden, you have drainage bed beneath it, you have a golf course, you have a football field, so you can put these to act as substitute for gravel. This is a construction and demolition plant at Netherlands. Beautiful. Wood would come out separately, the rebars would come out separately, but important thing to see is the way the waste was being, what it comprises of. This is large, and this are the rejects which are coming out, and eventually see this mound. So it's a processed construction and demolition waste which you can use, and it's an expensive operation. And finally, some shots. I just showed you a composting at Hyderabad. This is the municipal solid waste. Plus, I think they were adding a little bit of crop residue or wood shavings. I don't remember. That's the municipal solid waste. So that's the windrow for the composting. That's the moisture being added every day, and that is turning. So you can't have the windrow very high, because to turn a very high windrow is difficult. You need a lot of mechanization. Here they have it. In some of our places we do it manually. So this is giving you, this is the compost. So learnings, many old composting plants and waste to energy plants have not been commercially successful in India. They're all working well in Europe and the Americas. America has a lot of landfilling tradition. It has a lot of land. Okay? Europe has very little land. There's so many countries which are land. Japan has no land. So they don't even bother about composting. They don't even bother about recovering energy. If they can, fine. If they can't, then it's incineration. Put in money to burn it so that this much waste becomes. So incineration is used as a waste transformation technique. That means they are going to reduce the volume of waste by burning it. So Japan is an island. They don't have land. So they burn everything. Europe is also into composting and burning, and waste to energy is big. America, landfilling is more than waste to energy, because there's a lot of public backlash against dioxins and other pollutants, because everything you process has a side effect to it. So in India, these plants have not worked because of quality of input. You can't use mixed waste to produce anything good. You have to have separate fractions. If you don't have it, you have a problem. And therefore, the quality of product will not be good. Professor Alapat was talking to me yesterday. He's just come back from Shimla after seeing a waste to energy plant. He says, sir, I can't believe it that pellet is called a RDF pellet. They are making a pellet. But he says it's wet, it is smelly. That means it has got biodegradable component. And he says there's no way it's going to burn. Who in the industry is going to take a wet pellet? But what are they doing? They're getting the more coarse material and putting it in a cylinder and pelletizing it, but it's got moisture in it, so they're not spending enough energy to dry it. things like that. Odor is a big problem. Wherever you set up a waste processing plant, there is an odor issue in there, and this is critical. So these plants have to be away from 3 kilometers away from habitat, or they have to have very stringent odor control measures, which are very expensive. In India, the biggest cause of failure is inadequate finances. I just gave you an example. If I can produce sand, which is 700 rupees, and the natural sand sells at 500 rupees, I have to subsidize the sand. Who's going to pay? So the tendency of a municipality is to think that, no, I am giving him a resource. I have given him raw material for free, so he should be able to sell it and make the plant run. In all the overseas countries, they are giving a tipping fee. That means here is my waste, and here is X hundred rupees extra per ton, so that is your subsidy, so now you can sell it. In India, we are not paying a high tipping fee for waste processing facilities. I am a great proponent of that, but people are saying, no, they should be able to make money from the waste as if waste is gold, which it isn't. Waste is neither coal, therefore it can't give you profit, and waste is also not cow dung or other things which will give you a beautiful compost. So that has been a big problem. So waste processing facilities require significant financial support for sustenance, and that will determine whether we are able to have successful facilities or not, and good input. And finally, I just want to end this slide. We've only talked about the municipal solid waste management stream, but we have an industrial waste management stream. We have a hospital waste management stream. In Delhi, there are 2 thermal power plants. So there's a thermal power plant management stream. Then there's sewage treatment plants. Is the sewage sludge hazardous, non-hazardous? Where does it go? And other waste. So a city will have a lot of streams, and all of them have to be interlinked. And here, sometimes everybody is doing things in compartmentalized manner. The Industrial Development Corporation will not talk to the municipal. So how do the wastes go from one stream to another? There are a lot of interlinkages. But nevertheless, integrated solid waste management means please integrate all your streams. So with this, I'd like to end here today. Just giving you an overview that what a big city like Delhi, how it's striving to manage its waste. And from a perspective of environmental geotechnics, for the 100 units that we are producing today, if in the next 3 years we can reduce it to 50, well, that's a great task that we have done. Eventually, we may be able to reduce it to 30. I'm not so sure we can make waste disappear within the next decade. So thank you, and we'll carry on in the next class.